Oh, sorry. Hi. Mm, Started before I want. Yeah. So, okay. I'm Roberto, and I'm going to teach you physics. I didn't know that I had switched it off. The switch it on the had switched the camera on. Okay. So I'm going to give you an example of what we saw yesterday about the least square minimization. Okay. This is a space in reality, in a real case, that a chef with a Michelin, I don't know how you say in English, Michelin or whatever you call it. A chef with a Michelin star told us, okay, that I really did. So let me get the data. So this chef, the problem is that I confused turn the camera on with the start recording. As I confused the buttons, so it started before. So yeah. So as I told you, this example of least square minimization is based on a work done by a Michelin star. I'm telling you his name. Michelin star, 1-star chef, that it did to calculate the number of rations. I don't know. Rations. Well, so when you eat, I don't know the name of the. Okay, haddock, for instance. Haddock is the fish, right? Haddock. And suppose that in your dish there is 80 grams of haddock, but not any part, but the most scrumptious part. Okay, I don't know which one, but it's, I think it's, I don't know the name. Sorry, I should have found. But okay, this ratio, a portion, right? A portion of haddock is not what I really want, but anyway, haddock weighs 80 grams. So it's a particular part that has to come in one piece. So it's been presented in the table because it's a very expensive, quite expensive restaurant. Okay, and this chef decides, he sees that the bigger the piece, the bigger of the size of the fish, the higher the number of ratio of portions you can get. 80 grams portion you can get. So, but there are parts that can be used for this purpose. Okay, like the head, the tails, the spine, the guts, yeah, things like that. So after some kind of week or several days, he finds he gets the data in a paper like this about the weight of the fish, okay, the mass in kilograms of the fish, and the number of portions that you can get. 80-gram portions that you can get. So we can make a table with that's important, to present the data in form of table, and then this is to gather the data, and then we're going to plot it and see the shape. So for a piece of half a kilo, this is minus 1, we get 2 portions to 80-gram portions. I don't know. Yeah, it's an example. If it doesn't match reality, if you're a chef and you see that doesn't match reality, you leave it in the comments. Okay, but it's an example. The numbers are realistic, not kind of. So for a fish of 1.5 25, 1 kilo and a quarter, you can get 5 portions. For 2 kilos, you can get 8 portions, and for a weight of 3.4 kilos, you can get 9 portions. Like that, yeah, you only see that the bigger the weight, the higher the number. But what if we plot that? Here, write the mass in kilograms. Okay, so it goes from 0 until 4, right? So it will be 2, and it will be 4. Okay, 1, and 2, right? 2, yeah, 1, 2, 3, and 4 kilos. This is the mass in kilos, and then the portion will be like this is 10, the number of portions. Okay, so that will be 5. So let's see our points. For 0.5, there are 2, so it will be like something like this. For how much? Half a kilo, 2 portions. Okay. For 1.25, that will be like 5 portions. For 2 kilos, 8 portions, so something around here. And for 3.4, rather here, 9 portions. Okay, so you see they're not randomly scattered. So we can face this problem using the least square minimization. Okay, least square, and we're going to see why. Least square minimization. Sorry. And yeah, to find, you see, what do I do? Get closer to this point or to the other point? So this process does it using finding the equation, minimizing the distance, the square of the distance to all the points. So it will be something like this. You know how to do it, but it is roughly how it would be. Well, if it was a straight line, but anyway, it's not as easy as it seems to draw it from this point. Something like this. Okay, something like that. So we could get the equation that relates the number of portions with the mass in kilos. What for? If we have the equation, we have the whole system characterized with only one equation that we can get in our pocket, in our calculator. Let me get a calculator. Should be prepared? Okay. I need the other calculator. Hold on. Yeah, I'm back. Be patient. In Spanish we say la paciencia es la madre de la ciencia, because it rhymes. Patience, yes. Well, it's not quite.